Good morning, everybody. Happy Wednesday. We're going to go over circuits today and explain the parts and the purpose. Just so you know all this before we review tomorrow, or I think Friday, we're going to do just the whole lesson is basically be a review. So look out for that. So our I can statement of the day is I can name the parts of an electrical circuit and explain the purpose of each of the parts. So what is an electrical circuit? An electrical circuit, repeat after me, electrical circuit. One more time, electrical circuit. Great. So a path or a line through which an electrical current flows. So that electrical current is our electrons moving through and the idea of like electricity moving. So a closed circuit is a path making a loop. A closed circuit makes the electrical flow possible. So in a closed circuit, if we look at that picture here, we're able to turn this light on in both of these pictures because the circuit is closed. It makes a complete loop, a complete circle. It goes all the way around. There's no breaks in it. There's no spots that it would turn off, anything like that. An open circuit is where the electron flow is cut short because the path is broken. An open circuit does not allow the current to flow. So if we look at these pictures, unlike the other ones, our lights are not able to turn on because there's either the switch is off or there's a break in it. So right here you can see the break, right? So let's go over the different parts of each. So first thing I want to talk about is the switch. The switch is simply a small gap in the conductors where you can close or open the circuit. When the switch is closed, the circuit is closed and the electricity flows. So this is the same kind of switch you would think of when you turn on a light in a room, right? When the light is off and the switch is off, then the light does not turn on. But when you flick it back on, that closes the circuit so it turns back on. So the purpose is to make it easy to open or close the electrical circuit, turning the flow of electricity on or off. A light bulb in a series circuit is used to determine whether or not electricity is flowing. So we can see whether electricity is flowing if the switch is on and off, such as shown in the circuit. When the switch is on, we see that it's an open switch, so it's a closed circuit. When the switch is off, it's a closed. Oh, I'm sorry, I did that backwards. When it's off, it is an open switch, so the circuit is open. It cannot be completed. When the switch is on, it's a closed switch, which makes it a closed circuit, which means the light bulb is able to be turned on. Next part we have is a cell. A cell is the power source in the circuit. It's often a battery of some sort or a connection to more electricity or more currents. If we think of in our houses and stuff, we really don't have like a giant battery that's running everything. It's connected to wires that go into the ground, that go to power lines that connect to like a source of where most of your neighborhood would get electricity from. So in that bigger sense, the power source, the cell, would be like where Duke Energy has its power sources. But in a small circuit like you would make in class, oftentimes it's just a battery. So the purpose is it internally converts stored chemical energy into electrical energy, allowing the current to flow from positive terminal round to the negative one via an external circuit. Basically, all that means is that we're able to get energy from it, that we're able to take the energy it has and make it into what we need. So in the use of a batteries, if you didn't know, they're filled with chemicals, and those chemicals are creating a certain type of energy, and then we're able to convert that energy into electrical energy to turn on things like our light bulbs. Conductors, which are usually copper wires that help us make a path through which electricity flows. So it has to be just like our lesson before on conductors. It has to be something that can allow the current to flow through. So oftentimes when we think of circuits, it's done with copper wires because they're cheap, they're pretty lightweight, and they're easy to they're malleable, which means we can change the shape of them to fit things we like to make, whether that's in a wall to attach to an outlet, or if that's in our circuit like you see in the picture. They're just the wires that are connecting everything together to allow the current to flow through. The purpose is it allows electric current to flow easily because of the makeup of their atoms. In a conductor, the outer electrons of the atoms are loosely bound and can freely move through material when electric charge is applied. So we've talked about this before about how conductor allow the electrons to move through them, where an insulator does not. It will block them. It will block them from letting them get past. Next, we have the load. The load is often a small light bulb or a buzzer that lights when the current is turned on. So we can see that it's working if that light bulb turns on. So the purpose is opposed to the power source, such as a battery or generator, which produces power. In electrical circuits, examples of loads are appliances and lights. So it's not what's creating the power, it's what we use to know whether it's on or off, right? We can't just look at a battery and know whether it's producing power or not for our circuit, right? We use a light bulb in that circuit with the battery to see if that battery is working. That's all I have for today. Thanks for watching.